Thank you. Come on. Welcome to today's great lesson. My great lesson today will be under polygons. And under these polygons, I want to measure my discussion on finding the interior sum total of polygons, finding the number of sides of the polygon, try to relate the exterior and interior angles of the polygon. And number 4, trying to name the polygons. I'm going also to discuss how the polygons are named. And then I'm also going to look at one of the examples to demonstrate how we can actually solve some related question to this area of polygon. Remember this, that a polygon is a closed shaped figure that has a minimum sides, that has a minimum of 3 sides. A closed figure with a minimum of 3 sides. For this case, we refer to it as a polygon. And realize that the sum interior angles in a given polygon will always be given by the relation that is 180 into bracket n minus 2 or 90 into bracket 2n minus 4. Realize n is the number of that particular, the number of sides of that particular polygon. For instance, if you have a rectangle which has 4 sides, it means we can actually divide that rectangle into 2 triangles. Are you together? We can only divide that rectangle into 2 triangles. Now, if we can divide it into 2 triangles, and recalling that the sum total of angles in a triangle add up to 180, then we'll take the number of triangles multiplied by the sum total of interior angles in a triangles. And by so doing that one, we realize that if the triangles have 4 sides, then the total triangles inside a rectangles are 2, and therefore 2 times 180, we realize that we get 360, and therefore angles in a triangles, in a rectangle, add up to 360. Now, the interior angles and exterior angles of any given polygon add up to 180. That is, if we take the exterior angle plus the interior angle, that one gives us 180 degrees. Now, to get the number of sides, in this case we denote it with n, we usually take 360 divided by the exterior angle. So n in all cases will be 360 divided by the exterior angle. Now, remember, polygons are numbered according to the number of sides they have. For example, if we have a polygon with 3 sides, then that polygon is a triangle. A 4-sided polygon is a quadrilateral. Now, if we move on to a 5-sided polygon, that is a pentagon. Now, the 6-sided polygon is an hexagon. The 7-sided figure is an heptagon. So a polygon with 7 sides, we refer to it as heptagon. An 8-sided polygon is referred to as octagon. And 9-sided figure, we can refer to it as nonagon. Nonagon. And lastly, the 10-sided polygon, we refer to it as decagon. Now, proceeding on, I want us to look at 1 or 2 examples, how to use this concept and how to solve some questions that are related to this area of polygon. Now, the question I want us to go through is that you're given a question there, which is the sum of interior angles of a regular polygon is 1080 degrees. So the question goes, find the size of each exterior angle. Now, you can recall from this under the solution that sum of interior angles of any given polygon is 180 into n minus 2. Now, for this case, we can use that relation to find the value of n. Once we find the value of n, then we can substitute to get the exterior angle. Therefore, it means 1080 degrees equals to 180 into n minus 2. By dividing by 180 across, we end up with n minus 2 equals to 6, which then implies that n equals to 8 sides. And by the discussion earlier, such a polygon is referred to as octagon, 8-sided polygon. Recall also that exterior angles is given by 360 degrees divided by the number of sides of that polygon, n. And from above discussion, we've already gotten n being 6. Therefore, we take 360 divided by 8, which gives us 45 degrees. If at all the question could have gone ahead and asked about the interior angle, then you can say that the interior angle is equals to 180 degrees minus exterior angle, which is 45, and therefore we get our interior angle being 100.